Welcome back to DemystifySci. I'm Shiloh.
I'm Anastasia.
This is the podcast where we search for theories and ideas that are going to change the world. We are sitting at a moment where fundamental physics has never been more rigorous or precise, and our experiments have never been so extraordinary or complex. However, if you've been following the show for a while, you know that Anastasia and I are very skeptical of what is being made of those experiments. In other words, it seems like fundamental physics has lost sight of the need for material mechanics in making sense of what their detectors tell them.
Our guest for this conversation is UC Irvine particle physicist and CERN collaborator Daniel Whiteson, an experimental physicist that has a deep familiarity with the abstract mathematics of fundamental physics. And we sit down with him for a conversation about whether or not it is worth putting our time and effort and energy into this project where we search for a physical, material interpretation of the mathematics of quantum physics. As with most of our conversations recently, we present this conversation in two parts. The first part of our conversation is about whether or not this is a scientific question or a philosophical question. We, Shiloh and I, believe that the question of what the mathematics of fundamental physics represents is not a philosophical question. But Daniel thinks that it might be, and so we have to spend some time figuring that out. In the second part of our conversation that airs later this week, we talk through our model. As you know, we've been writing this book, Paradox Lost, The Material Principles of Natural Philosophy. It's on pre-sale right now, so pick up a copy if you would like to see where we're going with all of this. But Daniel actually is gracious enough to give us the opportunity to present our ideas for how we think the fundamental material world of physics might operate.
It was a real treat to be able to try our ideas on with a particle physicist, particularly one as notable as Daniel. He is really well spoken and capable of listening to our ideas and responding to them in full. I think you guys are going to love this. By the way, we can only afford to do this because you guys support us directly, which means that we work directly for you. So consider actually making sure that we can continue to make this project better and better by checking out our Patreon page. It's patreon.com/demystifysci. There's a really, really beautiful community of fellow explorers that are hanging out, and we get together every Sunday and try to make sense of the world around us. And I would love to meet you there. So check it out.
You can join our Patreon for just 75 cents a week. We set that level because we know that times are hard right now in the world, but through the power of large numbers, if even half the people that listen to this podcast gave us 75 cents a week, we would be able to launch this thing into outer space. It would be incredible. And so I hope that you come over to patreon.com and join us there. If you're not a big fan of like subscriptions and recurring charges, I totally get it. There's a couple of other ways that you can support the podcast. The first is that we have merch. We have t-shirts. The designs are all Shiloh and Anastasia originals. And so if you want to support the podcast and you are in need of some clothes, check it out. If you are into music, you should pick up our record. We have a band called Secretary of Nature. We've just released our first album on vinyl. You can check it out on Bandcamp. The link is in the description below. And if you like it, consider picking up a vinyl copy for yourself or your friends or your loved ones, because who does not love an excellent vinyl record to add to their collection?
That is absolutely the best way to enjoy this music. There's a lot of music in between the songs, and I think you're going to love it. You can also support the podcast one other way, which is grabbing a copy of our book before it even comes out. We have just put it on pre-sale. If you want to be one of the first people to read this book when it comes out, you can grab your copy on pre-sale. The link is right here and in the description.
All right, before we get to the conversation with Daniel, here's a little sample of our music, and enjoy the ideas and let us know in the comments if you think that the search for material mediators is a scientific question or a philosophical one. We'll see you next time. The way that we ran across each other is that we have a Twitter account where we constantly post these videos. Well, you post to it without, necessarily engaging with the timeline. Shiloh's responsible for all of the videos. He makes the videos and he posts them. And
Cool.
So I come and I harvest the reputational gains from Shiloh's hard work.
Nice.
But there's a couple places where recently I've been coming across videos, and as we work towards publishing our own work, I've been noticing that there's places where there's gaps in our understanding of fundamental physics. And I comment about it. And I comment about it in the sort of glib, kind of offhand way that encourages discussion on Twitter. And you came across one of those posts. I think it was the one with the dinosaur on the trampoline. And I was like, nobody understands what is the cause of this, which is the fact that there's a dinosaur on a trampoline, a bowling ball comes, and as the trampoline is pulled away, the dinosaur kind of hangs in midair for a few moments before it starts to fall. And there was another video that I think you interacted with, which was about, what is charge? What is an electron? What does it mean to understand these things? And you and I kind of started talking, going back and forth, and I realized that you engaged with the ideas in a way that was pretty unique, because I feel like most people in your position are just instantly dismissive and are not at all preoccupied with trying to understand where somebody's coming from. And it also seems like we could have a really interesting conversation about, are we missing something?
Yeah.
Is there some way that we're approaching the world where our search for explanations is somehow like misguided or incomplete or just needs tweaking? And so this is why we have come all this way, because we wanted to sit down with you. It's a lot easier to do in person than it is to do through Zoom. And I guess we should start with this question of, what does it look like to have an explanation? Is that fair, Shiloh? I know that this isn't exactly
I
what
was
we
gonna,
gained.
yeah, I was gonna just ask, like, what was it that you were reaching out to us about originally?
Well, I love interacting with folks who are interested in the questions of the universe. There's so many people out there want to understand, how does this universe work? These are questions kids ask because they're deep questions about being alive in the universe, right? And we have this whole project in physics of trying to assemble an understanding of it, but it's not always satisfactory. And I want to help people understand what we do know, what we don't know, especially what we don't know, because it's huge. And so I'm always looking for people who are curious about that stuff. And yes, there's a lot of folks out there operating in bad faith, trying to confuse people about what we do and don't know. And I always try to assume everybody's acting in good faith, that you're curious, you're interested in this question, let's have a conversation. And I have some understanding of it, certainly imperfect. Other people have other understandings. Let's engage and see, if we can help each other understand something better. That's where I always try to start from. A lot of times they go down weird rabbit holes, and it turns out somebody's just trying to bash academics. Then that's fine, and then I'll just stop engaging. But you guys seem to be sincerely interested in these questions and looking for an explanation. And, I feel like that is the job of physics, is to try to explain the universe around us in terms of intuitive concepts that make sense to us, right? I don't know that that's possible. I'm not sure that it's ever going to be a moment where we're like, yes, I get it. The whole universe, I get it. It makes sense to me. I'm not sure.
It's a big place.
And I think that we might disagree about that based on some of the comments you made, but I think it's worth doing, and it's worth understanding the edges of our, where we can get with that. And I think also there's a lot of misunderstanding about how much we do and don't understand how much physics claims to know. Like questions about mass. Like if you just say broadly, what is mass anyway? Nobody knows. Well, we know some things about it. We know a lot about it, and we have incredible theories that can describe what will happen to mass, or why mass bends the path of light, and all sorts of stuff. It's very sophisticated understanding. So like to say we don't understand it feels like it's, minimizing centuries of progress. On the other hand, basic fundamental questions about it are still unanswered. Absolutely. Maybe more in the philosophical realm, but right where physics meets philosophy is, I think, where the juice is. Because physics tells you, okay, we built a system, a mathematical system of equations that can predict your experiment. And most physicists will be like, cool, we're done. But many people, including philosophers, will be like, hold on, we're getting started. Like, okay, you have a system that works this way. What does that mean about what's real? And can it be the only explanation? And to me, that's where the exciting is. Like, all these physics questions are fun because of their philosophical context and what they might mean about what's really out there in the universe, which is, in my view, like what physics is about. And Yeah, so that's where I come from on these questions, is that you can't stop when you have some mechanistic explanation. That's where the questions come from, in my view.
Do you mean an equation that parameterizes it, the
Yeah,
system? Yeah.
yeah, or describes it and helps you predict future experiments. Like take quantum field theory, right? Quantum field theory, beautiful piece of work, incredible, sophisticated. The edges of it beyond my understanding. I'm an experimentalist, not a theorist, but I can appreciate that. It provides us a way to predict what's going to happen when we smash two particles together near the speed of light with extraordinary accuracy. That's incredible, right? And yet, as you guys have talked about on your show many times, like, what does it mean about what's out there in the universe? Is that a final answer? Does it explain things the way that we need explanation for? Because in the end, physics is about translating the universe into our intuitive language, right? That makes sense to us. Explain the unfamiliar in terms of the familiar. Sometimes that's possible. Sometimes I don't know that it is. Like, think about how we explain quantum particles or photons. In popular science, you hear all the time, it's a particle, it's a wave, it's kind of both. There's this duality. To me, that's like obviously the limits of our intuition. We're trying to explain this thing which has no analog in our intuition. You didn't grow up with anything photon-like. Nobody did. And then you run across this thing in your experiments and you try to describe it in terms of mental natural language and you struggle. It doesn't map to one thing. So you try to map it to two things, which feels awkward because those two things are very different. And the reason it feels awkward is that it's not a complete mapping. It's like if you taste a fruit nobody's ever tasted before, and you're like, oh, it's kind of like a cranberry. It's kind of like an apple. It's not an apple. It's not a cranberry. It's not sometimes a cranberry, sometimes an apple. It's its new own thing, right?
The appleberry.
The appleberry or whatever, the pineapple, I don't know. Like, could you describe a persimmon perfectly using other fruits? No, it's its own thing. I don't know if there's like some space of eigenfruits you can map it to or whatever. But my point is that there may be things out there in the universe that cannot be translated intuitively into our natural language. And that's frustrating. And that's where I think where a lot of the struggle
Do you
is.
think they can't be, or it's just we haven't pulled it off yet? Like, it reminds me of the cartoon where all the people are standing around, the scientists are standing around blindfolded, and they're all petting different parts of an elephant.
Yeah.
And they're not wrong. Like, each one's describing what they're feeling with their detector or whatever. Their equation describes some elements of the
Yeah.
system, but they just haven't put the whole thing together. That this, oh wait, this isn't a snake, and I don't know what all the other pieces of the
Yeah.
elephant are, right? They're like, oh, it's an elephant. And it's just, you know, I just tend to, at least personally, hold out faith. And looking back across the history of science, that people will put things together that seem irreconcilable eventually.
Mm.
Well, I think that there's actually a really relevant example of this that appeared in your book. So you wrote this book, Do Aliens Speak Physics, where you're going through and you're talking about, what would it mean to contact another civilization that is advanced, and would they see the universe in a similar way to us? And you have this interesting example at the beginning where you're kind of talking about the nature of science.
Mm.
And you talk about how perhaps aliens could arrive that don't actually have a deep scientific understanding of what it is that they've done to get here. And you use the example of a swordsmith that in the Bronze Age is just combining chemicals in some quantity because somebody told him to do that. And the sword that he gets is incredible. It's just perhaps even beyond what we can manufacture today because the knowledge is long lost and nothing that we make will survive another 5,000 years buried in a cave in Turkey. But that feels similar to what you're describing in the realm of physics right now.
Yeah.
Because what you're saying is that if we take these collection of ingredients and we mash them together, we know what's going to happen.
Mm-hmm.
The swordsmith can say the exact same thing. But then if you ask the swordsmith, yes, but why does that happen? In the example of the swordsmith, we would say that answering the question of why you combine tin and copper and you get bronze is a scientific question. That's not a philosophical question. It has to do with orbitals. It has to do with atoms. It has to do with chemistry. It has to do with heat processes and thermalization.
Maybe bringing up like Pearson or something is a good example of this.
I think so, but I think that even here, it's like I think that to say that asking the question of why does it happen like this is philosophical is not really enforcing that question equivalently over the course of human development. And I think that's not fair.
Hmm.
Because you wouldn't say that the question about the sword is a philosophical one, I don't think.
Yeah, I think that's right. I think I would say that's a scientific question. And in the book, I think I was trying to argue that aliens might not have that question. They just might not care. Like, why does it matter? In the same way that, like, I make a souffle and I'm not a big fan of chemistry. I don't understand the chemistry that happens there. I don't need to understand it. I just want to have the souffle. And for some people, that might just be enough. And other people are like, how can you not want to understand? It'll help you improve your souffle. If you really knew what was going on, you'd know if your salt and butter were the wrong temperature, then obviously it's going to improve your cooking. And that's great for some people. But that's my point, sort of, is that it's an emotional reaction or a cultural reaction to the universe to want to know in a way that satisfies you. And the point I was making there is aliens might have a different reaction to that. And and I want to answer your comment also. I love your faith that we will eventually figure it all out. And you're right that in lots of moments.
I don't know about
of
all, by
history-
the way. I'm just
Okay.
like, maybe there's a limit. Maybe we'll ever creep closer to it.
Yeah.
But I wouldn't want to just write off the possibility that a photon will make sense in 2030 or
Yeah.
something even.
And that it's possible to make progress. Absolutely. And you're right. There are great moments when things seem mysterious, and then we were able to explain them, and huge leaps forward in our conceptual understanding. Absolutely. But I don't know that we're guaranteed that for it to ever make sense, because our experience is limited, right? Our intuitive mental language, the ways that we feel satisfied, as you were saying earlier, explanations that click for us, that's an emotional thing. And one person might be like, I get it, that's enough. Another person might be like, no, man, that's not enough. I need to know what's below that and why this and not something else, right? It's not like some universal standard. You can say this explanation must be okay, good enough for everybody. It's about people's diverse curiosity. But I think that a lot of the way we explain the universe comes down to the way we think, which comes down to our experience and our intuition and our senses also, our sense of time, for example, and our sense of space and things that we experience. And there's no guarantee the universe can map to those things, right? You guys talk a lot on your show about mediators and, mechanistic explanations, and it's a wonderful analogy and useful for some things, but I don't know that we're guaranteed to find an explanation of the universe that clicks in that particular way for you or for everybody.
I think it's funny because other disciplines could have made this leap at some point as well, right? So biology was utterly possessed by mathematicians at one point in time when they discovered biostatistics, and they were able to.
This was like the era around the turn of the 20th centuries. The hereditarianists and the biometricians, led by Pearson, I think is who you're talking about.
Yeah, I mean, you can just imagine a universe where they had incredibly predictive models of heredity, and they packaged them based on the gradients by which these cells would transmit information and the localization. You could just imagine something akin to a quantum field theory of heredity. And it was extraordinarily predictive, and you could look at a cell and analyze its heritable characteristics and make these incredible maps of what would happen next with 20 significant figures of accuracy.
And it would be probabilistic. There would be a lot of uncertainty, and the wave would not collapse until the child was born, and you could actually look at it.
Wow.
Yeah, you could just have imagined that happening. I guess the same thing could have happened in chemistry. There's all these points where people could have just stopped with predictive models and mathematics, and we could have silenced the voices of Rosalind Franklin and Watson and Crick. We're like, wait a second, I think there's actually a material substrate that encodes all of this information that y'all are on about. And so you could imagine that people would have been like, oh, that's silly, who cares? It's not important, it doesn't matter, we have good enough models, we don't need to mess with that. And they might have been right for a while, but would they have come up with immunotherapies and molecular medicine and CRISPR-Cas? And it's like, those technologies wouldn't have been missed because nobody would have known that they were possible. And so I wonder if the same thing might be true for our physical paradigm. I mean, we have incredible electromagnetic manipulation capabilities. I mean, look at all of this, right? We don't have any idea, we don't have any sort of material basis for the electrons flowing in these circuits that people are on the same page about. And it's
What do you mean when
fine.
you say material basis? Because like we can explain all of it using
We,
quantum field theory and quantum electrodynamics, but
which are just like descriptive maps of the territory, right? But
Like, one has to ask if it is possible to consider a force to be the fundamental actor in a story.
can I just close down this one little point, which is that those maps might get us really, really far. Like, we have spaceships flying around, everything's great. We're recording this Zoom meeting on these incredible high fidelity cameras and everything. But what are we missing? Like, what technology might occur in the future if we were to realize the material basis of the electromagnetism that is at play here? I don't know. I don't know that anyone knows necessarily. That's all I wanted to conclude.
I think that you're exactly right. And Shiloh and I talk about this all the time, and obviously we're on the same. Well, I don't know that we're on the same side of. We're actually on opposite sides of most questions, but this is something that we agree on, which is that there is something about the ability to visualize that allows problems to suddenly become something that is tangible and solvable. Like, if you think even about Feynman, who is deeply mathematical, he had synesthesia for mathematics. The reason that he could operate in a purely mathematical space is because he literally saw the equations as having different colors. And that's not the way that most people interact with equations. They don't have this like deeply physical, intuitive relationship to them. And so you have to ask yourself the question, okay, so you have this language in which people speak that is descriptive. And somebody who can speak in that language in a way that's very synesthetic might be able to understand the mathematics so deeply and so intuitively that they're able to map them onto some other visual landscape that allows them to toy with them in their heads. Because I don't think that anybody, I actually don't know if this is true or not, and so I'm going to say this more carefully. I doubt that people think in pure abstract mathematics. Perhaps some do, but I would bet that it's vanishingly small. Like, I think that most people think in some blend of images and quantities. But the vast majority of people tend to be visual thinkers. And so I think that it behooves us to come up with a way of thinking about fundamental physics that is visual, that is intuitive, that can be seen in the mind's eye, if we want to open the doors to as many people as possible to be thinking about these questions. What is it?
I don't know. I just don't think like DNA is a nice visual tool. Like, I think it's literally there. Like,
that's true too.
It's actually how the nature works. It's not just like a convenient fiction. I mean, visualizing is cool and stuff, bring people into the fold, I agree. But also, like, understanding the reality of the situation is really important, right?
But the problem with the DNA thing, though, is that that's not what it looks like. Like, the picture of DNA in a textbook is absolutely a convenient fiction. Like, it's a
I don't know. We've AFM imaged some of them, unzipping and doing all these things.
Yes, but it's like, and you can, like, in some small context, if you unzip it under an AFM and in like pure crystal form, it will look a specific way. But if you're thinking about how it looks like inside of a cell, it has crazy structures, it's wrapped around histones, like it's.
Yeah, but it is a material object.
I agree.
Sorry, we're just rambling. Go ahead.
This is super fascinating. I think I agree with you. For me personally, visual explanations are the best. I think geometrically. When I think about mathematics, I think about, lines crossing, not equations on the page. It makes the most sense to me, but I also think that's very personal. And like we know also that geometry and algebra are the same. They're just different ways to explore the same fundamental mathematical relationships. And I've definitely met people who are definitely more algebraic than geometrical. I sat next to a guy in grad school who turned out to be a theorist, and he like worked problems on the page and he saw the connections on the equations, and I had to like imagine shapes interacting. And this guy was like so into it. He had like 3 different fonts for every set of homework because he was so into writing things down. So people are different kinds of thinkers, and people accept different kind of explanations as intuitive and satisfying, which brings me to your point, like DNA is real, quantum field theories are convenient fiction. What's the difference? From my point of view, everything is an explanation that's an imperfect, not exact, description of an effective description. Nothing out there is fundamental. Nothing we've explained is fundamental. In the same way that, like, I can think about planets as, mostly a point mass, as a sphere when I'm doing Keplerian, dynamics in the solar system. That's not what it really looks like. There's lots more details there I'm brushing under the rug. Every description we have is an approximate effective description that applies to DNA, right? There's lots of details that are missing in the typical picture, but it's a useful way to think about it in some contexts. That's true also for quantum fields. We don't know what's underlying quantum fields, but almost nobody, I think, in like the cutting edge of theoretical physics believes that quantum fields are fundamental in the universe. And I may be going on a limb here, but nobody believes that forces are fundamental in some way. I mean, forces are like a limiting case of what happens when two fields interact, right? And it actually also connects to the question of charge. Like the way I think about charge and forces is you have quantum fields in space, and for some reason we don't understand, we have lots of different fields, but those fields intersect with each other. Like the photon field and the electron field interact with each other. And why do they interact? Because there's a charge. The charge is not part of the electron, it's the relationship between those two fields. It tells you that energy connects between those two fields. And there's a term in our Lagrangian that represents that connection. That's what charge is. Charge tells you which other fields one field will interact with, will allow energy to slop back and forth with. What are forces? Well, the universe, for reasons we don't deeply understand, prefers a configuration of fields that have a static action. Action is this weird term in physics we've adopted from English and given it a completely separate name, which is very confusing, and I apologize. But you can express this thing action, and if you solve a system in a way, the dynamics of a system are such that they will minimize the action. The path of least action is the one that nature takes, right? And so if you have two fields where energy couples between them, then the path of least action ends up being described as this field is pushing on that field, or this photon is pushing on that electron, or this electron is repelling that electron. But from a field theory perspective, it's all just about energy sloshing back and forth between these fields. The charges are the thing that connects the fields. The forces is sort of like your low energy effective description of what happens when those fields intersect. So I don't think anybody thinks forces are fundamental. I don't think anybody thinks quantum fields are fundamental. And I don't think anybody sees them as anything but a useful fiction, and definitely an imperfect one. Everybody knows that they're not perfect because we haven't described gravity or dark matter or dark energy or huge questions about the nature of the universe. They're today's best map of the territory. And I would say DNA is the same thing. I would say everything in science is our map of the territory. We're going to keep going. There may be no fundamental layer of truth out there. We may just forever be getting better and better descriptions of what's happening out there, replacing one story with another, maybe never finding the truth, maybe meeting advanced aliens and to find they're 20,000 layers deeper than we are and still haven't found anything down at the base level. So, in the end, science is about finding your intuitive explanation for what's out there, and everybody's curious about stuff at different levels. I've learned enough biology in my life. I don't need to go any deeper. My wife will just like keep going, until she's satisfied, which maybe never. And she doesn't want to hear about quantum fields, except at dinner sometimes. And so, but that's the beautiful thing about science, right? Is that we have a diversity of interests. Some people think some questions are boring. Some people are fascinated by other questions. That's why we've, as a species, learned so much about so many weird things, and so but fundamentally, I think that all of our explanations are useful fictions, and we have no guarantee philosophically that any of them represent the real story about what's happening.
That's hard to disagree with. I wonder if you could like pick apart your field charge
Yeah.
explanation thing, because
We start before that though,
yeah, go ahead.
with the planets.
Yeah, go ahead.
Yeah.
So, like, you said something really interesting, which is you were like, you can approximate the planets as point masses if you were trying to study the solar system at a certain scale.
Yeah.
You would be wrong, though, if you said that they were point masses, though.
Yeah.
And so
Jupiter is not a dot. Yes.
And so that's the thing that I'm trying to get to, is that, and I think that we're trying to get to, which is that to some degree, there appears to be a thing that is called reality, which is that you can treat it mathematically in many different ways, depending on the context, and you can shift your position of study
Mm-hmm.
and understand it in a different way.
Mm-hmm.
And yet, there is a thing that you are stuck wrestling with, which is that there is an object at this location with this velocity, with this angular momentum, with this composition. And if you assume that all that you need is to just treat it as a point mass, do you ever go to Mars? Do you ever send a satellite to Jupiter? Do you ever like push towards it in any meaningful way? If you're like, well, it's a point mass and we understand kind of like the math of how it moves, and it's like there's not really anything there to why would you go there? There's nothing there to study. It's not a real thing. It's just it's got this force field around it that tells it how to move, and it interacts with this other like much heavier point mass particle that's at the center of the solar system, and it's all just points. Like why would you ever study
Well,
it?
even worse, you might not understand why it's interacting with that other point mass thing.
Yeah.
Which is what
danger,
leads us into this like charge field thing.
Absolutely. But every time we do science, we can only do it by making approximations. We can't be like, look, I'm going to take every detail seriously. I'm starting from the strings, and then I'm going to try to predict the weather tomorrow. Like, you're going to get nowhere, right? You have to zoom out and say, I'm going to start from something useful, or I'm going to get bogged down in an infinite number of calculations that might not change my answer, right? And so that's why if you're answering one question, it's fine to treat Jupiter as a point mass. If your question is like, well, how much is Jupiter tugging on my satellite? It doesn't matter if Jupiter is a huge, massive ball of gas or a point. But if you're, going to go probe Jupiter and you're sending something into there, then certainly you want a different model. And that's why different models useful in different contexts.
I think this is fundamentally the difference between science and engineering, though, which have been really, really blended up in the finest blender on earth, as far as I can tell today. Because we're so technologically successful that we feel like if we can manipulate these situations, that we've done enough. And honestly, that's a reasonable argument. Like, I don't necessarily think those people are wrong or anything. Technology is amazing. I love my technology a lot. But I think science is more preoccupied with the cause of phenomena. So if we go back to your example with the fields interacting, I already think we're off on the wrong foot scientifically talking about fields interacting, because a field is a map of effects. And interacting maps of effects is not a physical story.
Why do you say it's a map of effects? To me, a field is just like numbers in space that we find to be a useful calculational tool. It's like a intermediate.
That's a map, though, isn't it?
Okay. A map of effects. Yeah, it's a mental model, right?
Sure, but it's not a physical substrate with extension that is capable of displacing other physical bodies, and you know what I mean? Like,
it tells you it tells you at every point in space what the description of that point. If that's not a map, then I don't know what a map is.
Yeah, let me just set it like let me back this up. So all words are essentially one of two things. They represent either ideas or bodies. All words. Now, like, not all bodies exist. Like, I can imagine lots of bodies. Unicorns, leprechauns, Harry Potter, monsters. But they still share something in common with bodies that do exist, which is that they have some sort of physical extension. They have surfaces which separate the inside from the outside, and there's a tangent point on the surface that points inward at all locations, right?
This is a description of our intuitive experience.
This is just words. This is how humans communicate. Like, all words are either bodies or they're ideas, and ideas are just relationships among bodies or relationships between other ideas. So you can infinitely compound abstractions and make more and more abstract ideas. But all words mean one of these two things. And so what is physics if it's not dealing with bodies, not only imaginary bodies, but bodies that exist, ones that have real locations in space? They actually have some sort of measurable or conceivably measurable distance to one another in the landscape of all bodies that exist, right? So you have to start a physical explanation with actors that exist, real physical bodies doing things to each other. You can't just start with a map of ideas, because ideas all terminate on less complex ideas, which eventually terminate on physical bodies that exist. There's just no way to prepare an explanation. Otherwise, you just have a description.
Or you live in a simulation.
I'm not doing that. But your description might be super powerful. It might be much more meaningful to civilization than what I'm talking about. But I still love the science at the end of the day. Like, I think that it's fascinating to understand how the bodies are able to interact in such a way to give rise to the phenomenon. Whereas somebody could say, yeah, but is that really going to help us, orbit this planet or whatever? And it's like, well, maybe not. You certainly don't need to understand that level of reality to achieve incredible feats of technology, as all of this electromagnetic equipment shows.
You didn't need to understand the chemistry of bronze forging in order to make the sword.
Right.
Yet, if you want to make insane metamaterials today, you do. So it's like, I just think that I think that there's multiple things happening here, which is that, one, I don't think that it is fair to bin this question of what are the physical bodies that underlie quantum fields as a philosophical question. I think binning that as a philosophical question is committing the same error of reasoning as saying that what is the physical bodies that produce bronze being a philosophical question. That's obviously not the case. And so by I don't know what the name of the
DNA that underlies
demonstration
genetics
is, but like a philosophical demonstration is that like these two things are fundamentally similar. I don't think that you can make the case that the reality of like current flow in a wire is fundamentally different from the reality of bronze chemistry. Though I think that some would try, and we can discuss that. But I think that if those things are not that different, then it is not any more of a philosophical question to ask, okay, what are the physical mechanistic reasons for current flow? What are the physical mechanistic reasons for gravity? Not mathematical ones, not ones that let us send satellites to Mars, like physical things, not field-based ones that are like, okay, so we have space-time, and at each point in space-time, there's a certain amount of curvature, and everything really moves in straight lines, but because of the fact that space is curved, they appear to move along no. What is the physical mechanism by which this occurs, not the map that tells us that will happen so. That's not a philosophical question. That's a real fundamental question of physics.
I think it depends. It depends on, are you searching for a deeper explanation? For example, you want to understand where fields come from. You want to understand, is curvature an emergent from something else? Like I heard on your podcast some woman talking about an ether theory, which unifies quantum fields and gravity and all this stuff. Like the desire to unify quantum fields and gravity, absolutely, that's science, that's physics, because there's a lot of that's unsatisfying about our description currently. Like the fact that quantum mechanics and gravity don't play well together at all. We don't have an effective description of what happens above the Planck scale, where both of them have to be accounted for. Absolutely, going deeper than our current explanation definitely is scientific. But I do also feel like you guys are probing on the edge of something which is philosophical, which is like, this explanation is unsatisfactory.
Well, no, they're not explanations.
Yeah, they're not explanations.
Like, look, the question is this.
Because they don't click for you?
No.
But I thought we agreed that, that's sort of subjective and intuitive.
No, because what I'm saying is that an explanation is a continuous frame by frame story of how something happens. And if you have to drop a frame, or if you have to drop an entire scene from the movie, and there's just a big black box, which is like things happened, or like, and then there's the cutscene, which is like, and you skip to the next part, like the box, like you have to fill that box. And so
what if the universe doesn't fill that box? What if the explanation isn't the way that you hoped it would be?
But isn't that akin to saying that we're not capable enough entities to figure it out?
Or that there is no mapping from reality to our mental language.
Isn't that deeply unscientific, though? That's sort of a magical thinking, isn't it? Like,
there's just no mapping.
There's no way to understand. Like, it can't be. It's just inconceivable magic. It's basically magic, right?
I mean, I'm not saying that that's the way it works.
Yeah.
I'm saying that we have no guarantee that it doesn't. Right? Well, we have no guarantee that the universe operates in a way that maps to our intuitive language. But not that it can't be described, that it requires magic. Like
what's the alternative?
Mathematics or your maps or whatever you describe. Our current approach is not magical or fantastical. If I can build, say for example, I come up with a theory of quantum gravity. I'm a super genius. I beat Ed Witten. I have a theory. It explains quantum mechanics and gravity. It's all cool. It predicts things that nobody's ever seen before correctly. Yay! I've won 5 Nobel Prizes. But it's not mechanistic in the way that you're looking for, right? You guys wouldn't be satisfied. But that's
Well, I think it'd be super cool. I mean, I would shake that guy's hand for sure. Like, don't get me wrong. I'm not trying to kick this art. Like, I think that is a deeply technologically productive art form for sure.
So, but what's unsatisfying
with serious value to it? I don't even think it's unsatisfying. I just think it's incomplete.
Pardon the interruption, but before we go on, I have to ask you for a favor. We are a show that is purely supported by listeners. We are not selling Giraffe Green King gambling beds with customizable app management API streams or whatever it is that people sell you on podcasts. I think they also sell Spanx. I don't know. The point is this. We need you. We need you to support this podcast because we really believe in the fact that this is not a billboard for advertisements. We do not want to turn into NASCAR drivers that are just covered in patches for cheesy stuff that nobody wants. Save us from that fate. Come over to patreon.com, sign up for 75 cents a week. Join us at the Sunday Salon. I'll see you there.
And to say that what's happening to cause that quantitative description to be the way that it is out of reach, I think is a little bit demeaning to the Enlightenment project of science and of being a human. I just see us as having infinite potential to understand the universe and act in a way that leads it to its greatest harmony. I mean, the alternative...
I would say it's an expression of humility to say that, like, it's possible for us to understand the universe, and it may be that our minds are capable and the universe's explanation is something that maps to our mental language, but I don't know that it has to be. And certainly we've struggled, right? There are a lot of things that happen in the universe that we can describe mathematically that don't have a satisfying explanation intuitively. Quantum mechanics, for example, yet. And that doesn't mean that we won't. Right. And I agree with you. I would love if they did.
Yeah.
I would love to have an explanation where I go, yeah, of course. Why didn't I see it? Now it all makes sense.
Yeah.
And I can go off and do something else with my life. But I don't know that that's ever going to be the case.
But it seems so sad to tell students that, you know, they have to settle for the fact that these irrationalities persist. You know, I think that we should at least encourage the side of that statement that you made, which is it's possible that there might be actual explanations underpinning these extraordinary descriptions that we've prepared, right? Because the man in your story who wins the 5 Nobel Prizes, he didn't explain anything. He just knitted together a bunch of descriptions in a self-consistent fashion, which would be extraordinarily prolific and productive technologically, right? That would be awesome. Like we need those people. We need lots of them in this world, for sure. But you wouldn't want to discourage the students from trying to make sense of the physical landscape at the same time.
Yeah. But I don't see it as sad. I see it as extraordinary. Like, if the universe works in a way that isn't intuitive to us, but yet it works that way.
Like magical?
No, not magical, mathematical. You know, if in that scenario where we have a theory of everything and it works and we can test it, et cetera, it's scientific, and yet it reveals something about the universe which is unsettling. To me, that's opening our eyes. That's learning. That's why we do this.
Why would it reveal anything about the universe that was? It's not a mechanistic description, right? So it doesn't say one thing or the other about it whatsoever. Like, you could say that I don't understand these results or why these equations look the way they do, but to just say that they happen in a way that can never be understood, it's not as accessible to your imagination. That just seems really.
Well, I hope that our imaginations can grow. I mean, an amazing thing about humanity is that our children can find ideas intuitive that we find confusing, right? This is why grandparents can't program VCRs. And so, you know, it may be that we stumble across some mathematical concepts which describe or map to the universe, to use your language, and we struggle to grapple with what they mean, but that, you know, some new version of Einstein or Newton or Noether grows up learning them and finds them awesome and intuitive and builds upon them and is satisfied with that internal language or expands our human internal language because they've been exposed to them as children, right? So I think that's the joy. I just don't think that your or our demand for a mechanistic explanation is necessarily going to be satisfied. And I think it's the reason I'm in this field is to be surprised by the universe, to be confronted by reality, regardless of my intuition or my demands for how it works. So I want to be confused. I want to be surprised. It's the same reason that I go traveling, right? I want to eat weird food with eyeballs in it that I never would have made before and might not have even called food, but like it's lunch over here, so let's try it. Oh my gosh, turns out it's my new favorite thing, right? So I think it's not discouraging. I don't think it's minimizing or demeaning the project. I think it's saying, look, this project could be bigger than we are. And it might force us to expand our mental language, and we might not all be capable of that.
Okay, I think that you were right, that the project is bigger than us. I think that not everyone is capable in not everyone is capable when it comes to participating in the project for a variety of reasons. And I think the biggest reason is that many people just don't care. Like, I cannot tell you, my family is really smart, very technical people. When I start trying to talk to them about these fundamental questions, like my dad's an electrical engineer, and we started asking him about the way that DC current behaves in a circuit, AC currents, like what is the meaning of ground in a circuit? This is a man who knows all the equations backwards and forwards. And over the course of the conversation, we realized that he had never actually thought, like, what does ground like mean, behave the way that it does? He's a great engineer. And so he doesn't care about these questions. We start talking to him about it, and he just is like, are you stupid? Like, do you not understand how electricity works? And I'm like, maybe I don't. And then we keep talking for a little while, and I keep asking questions, and then after maybe like 10 minutes of him just being like, I'm terrified. Like, you have a science podcast? Like, you who doesn't.
He said that.
he's like, Nastusha, this is terrifying for me. And it turns out that after 10 minutes of talking, he's like, oh, wow, I actually never thought about that. And so it's just this process of him. He goes through this thing where he's like, this is dumb, this is stupid, nobody cares. Oh, wait a second, that's actually.
Oh, that's what you're asking.
Yeah, and then all of a sudden he's like, wow, I never actually thought about it. And then you can see that his brain, like some flywheel in his brain catches, and he's just like working through things out loud. And it's so cool because he, in that process, is discovering something that he hadn't thought about before. And it's revealing something to him that he hadn't really, after, I don't know, 45 years of working as an engineer, he's thinking about for the first time.
Yeah.
And so I think that it's valuable in that sense, but it's not for everybody because not everybody's interested in that project.
Although I think almost anything in science
is like that.
If you spend 5 minutes with somebody studying like spiders in the rainforest, you might be like, who cares? And then 5 minutes in, you're like, what? They do that? That's incredible. Tell me more.
Yeah,
that's the amazing thing about science. Yeah.
And so I think that the quest to ask and answer the question of what is underneath the fields, because I think that we can all accept that, okay, so fields is a map of what will happen at a point in a certain context. Like the electromagnetic field tells you what's going to happen electromagnetically. The photonic field tells you what's going to happen photonically. Like there's a bunch of fields that
there's two fields of the same.
They are. I know. As I said that, I was like,
it like tells you what your little test charge will do at some location.
Yeah.
That's true.
I should have said like gravitational forces, but yeah, you're absolutely right. I appreciate the correction.
I just want to be clear too. Like I'm not in any way attacking your approach with your students. You seem completely balanced about this compared to like I had physics teachers when I was in college who were just like, this is a stupid thing to be concerned with. It doesn't matter. We're never going to figure this out. It's beyond the human capability to understand these things. Like I literally sat in front of old men with gray hair who told me this stuff. And I see it sometimes in the fringes of popular media, and that's the part that I feel is a little bit tragic because as a student, I kind of bought it at first. I actually went into neuroscience. It was that's what I did in undergraduate because it was a brand new field at the time. And the professors were super excited and thought like there was all this work to be done. And the physics guy, my advisor when I showed up was a physics guy. He just made it seem like go home kind of, like, we've got everything figured out here, buddy. Like,
Mm-hmm.
there's nothing to see. And that's that's what I meant by the like risk of it being tragic for some.
And I understand, like, physics has a terrible history and reputation of dismissing other fields as, like, trivial applications of physics or uninteresting. Especially, I think the relationship between physics and philosophy needs a lot of repair. A lot of people in physics departments are asking specific questions they're excited about, and a lot of them don't think the questions being asked by philosophers of physics are important. And, like, okay, everybody can be interested in whatever, but let's have respect for what other people are curious about. And I think that for a long time, academic physics has been like, shut up and calculate, or who cares what's really going on underneath. But I think that's an old story. And I think a lot of people now are curious. I think a lot of those folks are in philosophy departments instead of physics departments, and so I think there's a lot of that happening. So to say, like, physics doesn't care depends on exactly your definition of physics. Because I have friends in the logic and philosophy of science department here. They have PhDs in physics. I read their papers. It reads like physics to me. It's just a question of which department you ended up in. I consider them physicists or philosophers. I don't know if they think of that as a slur or not. But I do think that physics as an academic community, hasn't always been super well behaved or respectful of these questions, which is a shame. And I think a lot of physicists don't even think about these questions. Like, if I go to CERN and I ask folks, like, hey, do you think the Higgs boson is real, in the sense that it's like there and even beyond our ability to observe it, that it's like, truth in the universe, or it's just a model that we've concocted to predict our future experiments? They're like, what are you smoking? Like, obviously it's real. They won the Nobel for it. Duh. What a silly question.
But that should be really alarming to you. That should be, and okay, so this ties directly into the conversation we were having at the beginning of this, which is that there does appear to be a fairly strong contingent of people in the world right now that are aiming at undermining the accumulated expertise of scientists in the world.
Yeah.
And the exact reason for that is when you ask the question, is the Higgs boson real? They're like, what are you smoking? That's why it's happening. Because people are looking at it and they're like, no, hold on. You guys have a mathematical thing that you've mapped. It's a map that you've created of the world. Is that map the real world, or is it a map? And when somebody asks that kind of a question and the response that they get is, what are you smoking? It's unbelievably disheartening and discouraging, even to hear the question of, okay, well, what is mass? Like, where does mass come from? A question that I don't think has an answer.
No, it has an answer. I would say it has an answer. Whether anyone's successfully convinced the rest of the party of that is a different matter.
But I think the problem there is you're asking the wrong people. Like, if you ask a philosophy question, because that's a philosophy question.
Okay, why is that a philosophy
physicists, then, like, because there's no experiment you can do to answer it. By construction, it's beyond our ability to probe. If you ask, is the Higgs boson there in a way that's beyond our ability to probe, or is it just, part of our explanation of what's happening? That's a philosophical question. It's, is it real in some deep philosophical way, which I think is important and fascinating, but some people are like, Jan, who cares? And so if I ask people at CERN, I've been asking people, the wrong people. They're not the people who are interested in that. They're people who are interested in building experiments and running them and calculating data and winning Nobel Prizes for discoveries. And that's cool. The same way, like, if you ask the guy in the rainforest who's studying spiders, is the Higgs boson real? He's going to be like, what are you smoking and where can I get some? And so I think
it's the toads, I think, in the rainforest.
or whatever. So I think, you just got to ask the people who are curious about these questions if you want serious answers.
I don't think that, okay, look, that's such a positivist perspective, right? Because if you were asking somebody, hey man, do you think that atoms exist?
Yeah.
Or do you think that that's just like a convenient map that we've made? That would be a scientific, it's hard to imagine that the question of, like, does an atom exist it's hard to imagine that being a philosophical question. That's not a philosophical question. That's a very real question of what is the construction of matter? What makes this table different from this controller, right?
It depends precisely on your definition of exist in that sense, unfortunately.
Okay, explain.
I mean,
that's great.
That's great.
Yeah.
Yeah.
Because it's a really important word, actually.
Yeah. Well, if you mean, do atoms exist in the sense that, like, do atoms exist beyond our ability to observe and interact with them? Like, were there atoms before there were humans thinking about them to do experiments on them? Then you, by construction, put it beyond the realm of experiment, which I think, personally, is the interesting form of the question, do atoms exist? Are they real and out there in the universe when we're not studying them, we're not using our calculations, when they're not influencing our experiments? To me, that's the interesting philosophical question, which is why I would define exist in that way. Somebody else might say, do they exist? Like, well, we have experiments that prove that they're there. We can image them. And, so if they exist means, are they a part of the model that successfully explains reality? Yes. Do they exist means, are they there beyond that experimental notion in a way we can probe? That's the philosophical question, which I think is fascinating, but other people might not.
Okay, so what I hear you saying is that this is kind of almost it's the category of question that asks whether the laser beam of human attention is the thing that creates both the category that we bin an object into and the object itself at the same time.
I'm not sure I totally follow that, but I think so. Yeah.
Well, it sounds like you're saying that your question is, do atoms exist, depends on human interaction with them, because you're saying, do atoms exist outside of us studying them? And
Because I think for it to be scientific, there has to be an experiment we can do to be like, well, the experiment would be this way if they didn't, and this way if they did. And in the same way that we can, like, do experiments to see, is the Higgs boson a useful part of our model? We can do that experiment, right? With the Higgs boson, it predicts one set of outcomes. Without it, it predicts another set of outcomes. So yes, we can do experiments to deduce whether the Higgs boson is a useful part of our model. Would aliens also have the Higgs boson in their explanation of the universe? Is it universal in that way that it's inevitable and the only possible explanation, that it has to be part of your explanation of the universe because there's a single objective reality out there that we can probe? That's a philosophical question that goes beyond our ability to answer with experiments, until the aliens arrive.
okay, so let's go back to like 1700.
Oh, okay.
No atomic theory yet.
Yeah.
People have been kind of saying that atoms might exist, something of the sort perhaps might be
Yeah.
down there, that there might be some building block that justifies why substances are different from one another. And then there's another worldview that says absolutely unimportant, we cannot probe it, ergo we have to construct explanations that have nothing to do with there being atoms or not. Is it a scientific question at that moment to ask whether or not atoms exist? Like, you don't have the technology to probe. You're another 100 years off from somebody formulating an atomic theory that is sufficiently capable of actually mapping onto the periodic table. You don't even have the periodic table yet.
Yeah.
You just have you've just barely transitioned out of alchemy, and some guy in the laboratory of the Royal Society for the first time has demonstrated that the thing that burns is oxygen and not phlogiston.
Mm.
Like, we're still at this dawn of chemistry. Is it a scientific question to be talking about atoms at that point? It's beyond our ability to experiment.
Yeah, that's a great question. I think some things are by construction beyond our ability to experiment because you put into the question, like, never observable. Other things, not currently our ability to experiment, like string theory. A lot of hoopla about, is string theory scientific or whatever. I'm not a big fan of those conversations because, like, who knows what advance is going to eventually lead to something that we can study? Like, nerds were playing with group theory for 100 years because it was a fun way to look at numbers. And then later we're like, wow, this describes the way quantum fields interact in an amazing way. It's beautiful. Turns out you can't retroactively be like, oh, that was science the whole time, guys. And so I think that anytime you're building a model to describe the universe and you potentially have some way to test it, then yeah, you're doing some science, even if maybe the way to test it is off in the future. I think that folks doing quantum gravity now are definitely doing science. And even if it takes 1,000 years before we figure out how to test these things and do those experiments, but there are some things that unless I'm not imagining it correctly, will will never be testable, because again, and you might critique like this is kind of a narrow construction, Dan. You're like carving out this thing by saying it's never testable. But I think that's the meaning you guys are looking for.
Well, I don't think so, because
No.
I'm like, in the 1700s, if you told somebody there is in a block of carbon of 12 grams, there are 6.22 times 10 to the 23 little spheres
Yeah.
that are nanocarbons that combine in specific ways to produce the phenomenological experience of carbon that actually, in a different lattice, also produce the phenomenological experience of diamond, that person would be like, you're an idiot. You're dumb. Like, leave. But that is the case.
Yeah.
And at the time, the idea that would have been possible to probe, that you would have an X-ray crystallography machine that could map the lattice of a substance by shooting beams of high energy light through it, watching how it scatters, and then performing a Fourier transform in order to reconstruct the organization of the atoms that produced the scattering pattern.
Pretty awesome stuff.
That's witchcraft. That's witchcraft in the 1700s. You'd be burned at the stake to propose such a thing.
Yeah, probably.
And yet, if you did propose such a thing, it would still, it seems impossible to consider a world where that is not a scientific question. And that's why people were arguing about it already. And I think that the thing that you say, where it's like, there's a bin of things that we will never be able to observe because it just seems impossible. I'm like, 300 years ago, the idea of the atom was impossible. Like, they had mathematical constructions. Like, do you know about the Boscovich point atom?
Mm-mm.
So the Boscovich point atom is basically the model of the atom that Faraday was working with. So the notion that stuff was made out of atoms is old.
It's not that different than fields, like, to cut to the chase, the Boscovich atom, right?
It's basically that you have a point source that is a true mathematical point, and it is surrounded by force fields. And the reason that some chemicals can come together is because their force fields are compatible. And other chemicals don't react because their force fields are not compatible. And the force rises infinitely as you approach the source of the forces. And so you can never get to the source of the force, and everything is just forces interacting, and that's how atoms work. And that was Faraday's model of the atom. That was Davy's model of the atom.
But what's crazy is, like, that's true. It's both incomplete. It's incomplete. It's not the full picture, right? It is true that you can represent genetics with probabilistic fields. It is true. It's not that it doesn't map onto reality accurately. It's just not the whole picture. And with respect to explaining experiments, I just wanted to mention there's tons of experiments that are really robust that I would say are lacking explanations, Like Newton's grand gravitational equation is well verified. Lots of plenty of experimental data to put our faith in that equation. But yeah, why does it do this?
Mm-hmm.
What is the cause? What is the material basis for it? What are the atoms doing to each other as they hold on to one another in their procession around the sun?
Yeah, so I feel like you're always reaching for that deeper explanation. Why this theory? Why this explanation? What's underlying all of it? And I think that's what physics is trying to do is we have an incomplete a set of observations about the universe, right? We never have full data. And we're trying to sketch a story about the unobserved portion, right? We're telling a story about the things we don't see. Fields are never observed. Nobody's ever seen a field, right? It's only, you see its effects on electrons or whatever. There's always some behind the curtains part of the story. And that's what physics is trying to do. It's trying to fill that in. And
Well,
so,
I hope you're right about that, yeah.
You can't fill it in if you say that it's philosophy, though. Because I think that that's where the problem arises, which is like, look, is it philosophy to ask, is stuff made of atoms?
Yeah.
Are atoms mathematical points with force fields around them? Or are they true objects? Like, that's a question that deserves an answer.
I agree. And I was trying to carve out a territory earlier about like things that are never observable. But I can take another attack, which is say like there will always be things that are not observed, right?
It is true.
Even if you develop technology, you will never have infinite data about the universe.
It is true.
Yes.
And so you never have a full revelation of reality. You always have an explanation about things that you do not see. And And, I think that you have no guarantee that your explanation is the territory. It's always a map.
It is true.
And because it's incomplete, imagine like you have 4 dots on a page. I draw this curve. You draw that curve. How do we compare it? Well, we can use chi-squareds, but what if they're equal? I don't know. I have an explanation. You have an explanation. What do we do if in 1,000 years aliens arrive and we have our theory of quantum gravity and it works and we've assigned 5 Nobel Prizes to our hypothetical physicists and they have theirs and it works just as well and it tells a different story about what's happening. Ours is mechanistic in a way that satisfies you. Theirs is bizarre and probabilistic in a way that satisfies them. What's real? We don't know. And that's why I think it's a
both of them
philosophical
are real.
question.
Yeah.
Both of them are real, even if they tell different conflicting stories.
Well, they can't conflict. I mean, that would be, I think that you can have 2 different ways of looking at a puzzle and they can both be accurate. I mean, I think that we have to be really careful here to make sure that we're on the same page about the difference between a description and an explanation. I see that cropping up over again.
Because I don't think I fully understand what's unsatisfying about a completely perfect mathematical explanation for every experiment that's ever been done.
It wouldn't be an explanation is the thing, that from where I'm sitting. It would be a description.
A description.
Yeah, so it would tell you what everything looked like from every conceivable angle. It might tell you how this will run forward or backward.
Right.
But you still wouldn't have any idea necessarily about how the physical actors engaged one another in order to produce the phenomena.
Okay, but so I think that this is excellent. Let's figure this out. Let's take, for example, where are quantum fields failing? Because in my view, quantum fields do both. They predict what's going to happen.
We do electromagnetic fields instead.
Fields, sure.
I'm much better electromagneticist than quantum physicist.
Let's live in a classical world. We're Maxwell. So, let's say the fields predict every experiment that's going to happen, but they also provide a story about the unobserved component, right? These fields and what they're doing and whatever. Isn't that the story that you're looking for?
Well, I think you've just converted your map into a physical actor, which is a real philosophical fallacy. It's like a legitimate philosophical fallacy called reification, right? Uh-huh. So you take an abstract entity. It'd be like kind of if I was like, hey Daniel, I'm gonna go to the bathroom. Can you hold on to my love for a second? You dropped it, right? Because it's a concept, it's an idea. Love is an abstract entity. It doesn't have a physical location in reality. It has no surface. It has no inward extension. And so when we start treating these abstract entities as if they're physical objects, I think we can fool ourselves into thinking we've actually explained something, when in reality we've just parameterized the description to a very fine level often, right, which is super productive, but it leaves something left, which is the explanation. The explanation would be, how it was that my body actually made it to the bathroom. Like, how did that happen, right?
How do you know the quantum fields are not real the way love isn't physical? How do you know the quantum fields are not physical?
Well,
I was arguing for an hour that we don't know that they are.
Yeah.
But I'm wondering what convinces you that they're not?
Well, let's just stick with the electromagnetic fields. I mean, they're vectors that have some dynamic component to them, right? Mm-hmm. So they basically will tell you how an action will unfold, mm-hmm. right? Mm-hmm. So that's a very abstract story, right? I mean,
winds are vectors, right?
Right. So all these fields are abstract by definition. Like I said,
a wind is not, to be clear, wind is not a thing.
Yeah, wind
that's actually that's a really good example
of little actors, right? So wind, I can actually explain wind very physically. I can give you a physical explanation for wind because I just use atoms. They're these bodies or gases, I guess. It could be diatomic, I guess, but they're bodies with surfaces that have elastic collisions with one another, and their displacements due to their thermal gradients. Some of them are wiggling more than others. They're pushing each other along. You can make a very physical story with no missing pieces from the story. There's no pages torn out. I can just tell you how wind works physically. I should be able to
accept that air molecules are physical things.
Well, that's the assumption, yeah.
But if we're drilling down, in the end, air molecules are emergent phenomena of, ripples in fields.
Well, you can't be a ripple in a map and have that be like a physical explanation. I mean,
but then you're assuming that it's not physical. I'm asking, how do you know that they're not physical?
Well, I think that in any presentation that's a physical presentation, physical science, it should start with physical bodies that have surfaces, locations which are defined with respect to one another.
But
inward
aren't
extension.
you assuming that the universe can be described and its fundamental components are things that are intuitive to us?
Yes.
Well, the room is like that, right? Like, there's nothing that would lead me to believe that that wasn't the case in the physical space. Like, I don't think I could describe my love for my mother using physical terms. That would be insane. But I can describe every single physical interaction in this room in terms of those processes that I just described to you.
But
Like,
what if our room is not a representative sample of the kind of things that happen in the universe and turns out to just be, an effective emergent phenomena? It's not something we could require the universe to be. Like, if we had only ever studied ice cream sandwiches, we might be like, well, look, everything in the universe has to be creamy on the inside because look, this one thing is. And you wouldn't accept that. You wouldn't be like, well, now if you're going to explain to me quantum gravity, it's got to be in terms of ice cream sandwiches. Be like, no, of course not. The universe, it's just something the universe can do. It has these properties under those circumstances.
You know what's really
not a
funny
requirement.
is that I actually think that you could come up with an ice cream sandwich theory of gravity that would be perfectly like if you had look, the idea
Let's
is
do
this.
it.
If you have really truly studied the ice cream sandwich down from its, you've looked at how it falls to the ground.
Yeah.
You've looked at the forces that bind its milky products. You've looked at like the reasons for why its biscuit is different from the milk.
You know a lot more about ice cream sandwiches than I do.
making me hungry.
If you have gone through all of this and you have truly understood at a mechanistic level what causes the ice cream sandwich to be ice cream and sandwich, and then you take those same principles and you apply them to understanding gravity, I don't think that there would be a gap there. I literally think that if you could explain anything to the level of saying, we understand from the level below the fields, what is there, how that stuff is moving to create the fields, what it looks like when it moves in such a way that it creates an atom, how those atoms move in order to interact with each other,
Yeah.
how light is an interaction between those atoms, what is the shape of the interaction and the kind of interaction, sorry, shape is wrong here, what is the nature of the interaction that produces electromagnetism? How does electromagnetism arise from the disturbance of the substance that underlies the electromagnetic field? Then you have an explanation.
I mean, I think we agree. Everyone wants to know what is the field? What underlies it? Where does it come from? We want to know that, right? Nobody's like, fields, cool, we're done, right? Especially because there's 19 of them and they have these bizarre properties and patterns and it just screams the way the periodic table screamed something else is happening underneath here. We all want to know that. So none of this is to say you must accept fields and be satisfied or in any way. But my fear is when we come up with the next thing, the schmeals that underlie the fields or whatever, you're going to be like, oh, well, that's just a map too.
Well, if they're physical, I mean, look, like I tried to censor this earlier. There's all words are one of two things. I'm just arguing for the idea that explanations in the physical realm must start with physical bodies that actually exist. They have a location with respect to other physical bodies. That's what I would be satisfied with. I'm not even saying that it has to be right. I'm just trying to say that it has to be consistent. Like, I need to be able to understand it. I need to be able to consider your theory. And I guess there's a little bit of confusion with this word theory too.
Are you saying it has to be understandable to be right? Or are you saying that's just...
I don't even need to do that necessarily. I just, when you ask me why would I be unsatisfied with the schmields under the fields? And I'm like, well, are the schmields, do they have physical composition in the way that I've outlined? And if they did, then I would actually find your explanation quite satisfying. Now, I might not buy it because there might be problems with it for me. You might have to bend over too far backwards to explain something, or it might introduce complications which are worse than the schmields that I was trying to make sense of in the first place, right? So it doesn't guarantee that you're gonna get to the answer. The only other thing I wanted to point out, which is quite curious to me, is that physics is one of the only places in the universe where an equation that describes something is, I guess economics is the same way, that you get to call that a theory. when I have a theory of how something goes down in the rest of my life or in other disciplines,
Yeah.
I need to tell some sort of actors doing something to each other, shooting the guy, putting the gun over here. Like there has to be a friend.
Shiloh's a film noir detective. And
Sorry, yeah, I was thinking about like murder mystery theories. Like I have a theory, Your Honor. Yeah, that kind of thing. So I think that word's like, I guess I see a lot of the problems with how we approach a really, like the future of physics, the future, and then maybe I'm using even the word physics is maybe inadequate, right? Because, we've talked so many times, is it science? Is it philosophy? I'm like, like, wouldn't it be better if our scientists were philosophically minded, if our philosophers were right?
100%.
Because because you see slimy people in politics do this too, where they're like, well, or in business where they're like, well, my job is to maximize shareholder value. Like you're like, yeah, but sir, like you're dumping toxic waste into the Cleveland River or something, and they're like, well, I'm just doing my job, and it's like, well, shouldn't your job be a little bit more than just I'm a guy who makes money? It's like, yeah, well, you're also a citizen of Earth. You live in Cleveland. There's people who live downstream of that river, but it's kind of like that at every level, right? I mean, I just feel like drawing these lines up between whose job it is to do this and that is maybe not what the future, any of us would want the future to look like 1,000 years from now so much.
I totally agree with you. And I think physics has a lot to learn from philosophy, and philosophy is informed by physics. Absolutely. Unfortunately, we live in this world where like academic departments exist and there are boundaries. And in my department, we tend to hire physicists, and in that department, they tend to hire philosophers. And, I wish there was a deeper connection. And, that's why I go hang out in the philosophy department all the time, because I think they're smart people asking interesting questions. But not everybody agrees with me. And some people think those questions are boring. And that's fine. And that's great, right? That's why some people are excited about this and some other people are excited about that. But that goes deeper, I think, even to this question of like, what constitutes an explanation? Because say we find Schmiels and you're like, no, that doesn't work for me. And then somebody digs deeper and they find, super Schmiels or something. And you're like, okay, this one I like. This one, the story you're telling is of little things with surfaces that can't overlap with each other. And I'm good. But then, Sally down the street discovers, oh, super Schmiels are just effective theories, actually. They're like an ice cream sandwich. They're actually made out of something else, which doesn't satisfy you. You're like, no, I don't like that. Those have weird properties that I'm not satisfied with. So, everybody digs as deep as they want to go. And I think my point of view is like, all of this is a story that we tell ourselves that makes sense in our minds. We go as deep as we want based on our curiosity, and nobody ever has any guarantee that any of it is real. And you're like, what about atoms? Atoms are real. And like, it's just a bit part of that story. And to me, I try to take the philosophically most skeptical and the route with the most humility, which is to claim least about what must be out there in the universe in terms of satisfactory explanations.
And yet, I think that we are stuck with having to push for something that is, I don't want to say universalizable. I don't want to say final, but I do want to say closer to true. I don't think that we ever reached, Shiloh really hates the word truth.
Well, I'll say one tiny little thing,
Yeah.
which is that we didn't just wake up one day and think of this, right?
Yeah.
I feel like we are pursuing a tradition which, when I try to, assess the, for lack of a better word, you could call it philosophical, but like the spiritual tradition of natural philosophy. Like, what the heck are these people trying to do? I think that's what Anastasia and I are trying to articulate here, is that they were trying to restrict their explanations in the physical space to physical phenomena, right?
Yeah.
You don't say, well, the Schmield's caused by my love for my mom or something like that, right? But some people would have tried that at some point. Like there was a deep confusion, the original astronomers in Sumeria were like totally mixing up all of their metaphysics with what was happening in the sky. And, Ishtar's doing this and...
Right.
Yeah. So, anyways,
That's
I
actually
went on too long.
that's a really fantastic point, because
that is it for the first part of this conversation. If you want to check out the second half, the link for that is going to show up on screen in just a second. It is also in the description. And we hope that you enjoy the next part, which is our exploration of the specifics of what it would take to have a material model of fundamental physics with CERN physicist and UC Irvine professor Daniel Whiteson. See you next time.